What's up guys? Welcome to our TechTrends special vlog / Christmas special edition. Okay, now in the previous videos that we had, we've discussed about resistance and we made a resistance meter or ohmmeter using Arduino. Now in this video, it's a special video because we will be bringing to you two projects in one video. So first is we will be tackling the world of capacitance and inductance. Okay, first, let's go for the capacitance. Okay, usually capacitance, the unit for capacitance is in farad, but the most frequently used unit is in microfarad. So, example for we have here our samples of capacitance here is in 820 microfarad. And you can read the values of the capacitance in the component itself. But in this video, we will be making or we will be turning again the Arduino to read the capacitance value of a capacitor using these tools and materials and equipment, of course, in order to create a capacitance meter via the Arduino. Okay, first we have these materials for this project. First is we'll be having these different values of capacitors for the testing later to check if the project is successful or accurate or precise in somehow way. Next is resistors. Well, these resistors should have a specific value. For example, for this is a 10,000 ohm resistor, and this is this small resistor. This is a 220 ohm resistor. So only two resistors are needed. Then of course we'll be having the breadboard for our circuit. The jumper wires, it is male to male jumper wires, and we have the Arduino Uno model, and our Arduino Nano will do, but as what I've said in the previous video, Arduino Uno is the default or standard model for Arduino projects. So again, okay now, so let's start. So okay now, we will be connecting the two resistors in series connection. Next thing is, we will be connecting the end of the 10,000 ohm resistor to pin 13 of the Arduino. This will serve as your charge pin. The same thing with the end of the 220 ohm resistor. We will be connecting it to pin 11 of the Arduino. This will serve as your discharge pin. Okay, looks like we have a complete path for the circuit, but still it's lacking. From the Arduino, we will be connecting the ground slot here to any point of the Arduino, to the board, to any point of the breadboard. Let's say we will put this, and then we will be putting along with the midpoint or the node between the resistor of 10,000 ohms and the resistor of 220 ohms, we will be connecting a pin that will be connected to the A0 pin or slot pins, A0 pin slot of the Arduino. So now we will be connecting the Arduino via the cable to the PC or laptop. Okay, so as I've said in the previous videos, there are still preliminary steps to do for you to enable the exchange of data between your PC or laptop and your Arduino, and that by that your Arduino will be recognized as one of the hardwares of your laptop. So by that you can upload your code from your laptop to your Arduino. Okay, now we will be uploading the code of capacitance meter. And it's uploading, and it is done uploading. So by now we can already test this circuit project if this result that will be displayed in the serial monitor is accurate or close to the actual values indicated in the component itself. Okay, now we will be testing the circuit. So first is we will run the serial monitor. So as you can see, it's still 0 because we still don't connect the capacitor to the circuit project. Now we will be testing our first capacitor. It is the value indicated here is 1 microfarad. So now we will be connecting. So take note that this black pin or black jumper wire is the ground, and so our capacitor is a polar capacitor, which means it has a positive side and a negative side. So in connecting this, it is important though the results will be the same as if the polarity of the capacitor will be switched or flipped. Nevertheless, let us practice to connect in a correct polarity. So the negative pin is the ground, and so it is a negative side. So we will be connecting it. This side of the capacitor is the negative side. So this will be connected to the ground, with its positive side connected to the A0 pinhole of the Arduino, which is connected through a jumper wire, yellow jumper wire. And so we can see in our serial monitor that the results are in 900 nanofarads, and as we can see, it is close. It is a bit accurate to the actual value of the capacitor. Okay, now let's remove the capacitor and let's try something else. Okay, the same procedure or method on how to connect. And here, as you can see, in the serial monitor, it is in 4 microfarads, and its actual value is 4.7 microfarads. Still a bit accurate. We will try another capacitor. Okay, so now we will be testing the third capacitor, and that is the initial amount here, or the actual amount rather, indicated in the component is 820 microfarad. And now let us test this if it is still accurate, because it's a high jump of value. The first two capacitors have values of 1 and 4.7. And now we will be testing 820, so it's a high jump of value. Now let's test if it's still accurate in this huge values of capacitor compared to the previous two capacitors. Okay, we'll be connecting the same procedure to connect. now you can see the monitor is slightly stopped or paused because it's in a big value. Okay, now so we're done with the capacitance and knowing its capacitance value through the capacitance meter in Arduino. Now we are now in our second part of our video, wherein we will be also tackling inductance. Okay, aside from capacitance, inductance is measured through the unit of henries, and it is also in microhenries, millihenries, and so on and so forth. Now, in the inductance, there are variety of forms and sizes for inductance. In inductance, in smaller values of inductance like this, the values for this range from 1 to 10 or 1 to 5. The low end values of inductance. So the forms or the structure of the component of the inductance would be like this, just like a resistor. And note also that there are also bands, color bands, that indicates the value or the amount of the inductance of the component. So it has also a legend, and you can also refer to the values of the inductance by its color band. Now, another thing is the same thing with the resistance. We can also use Arduino to know the rough estimate of the value of the inductance, and that will be going to make in this video, in the second part of our video, the inductance meter in Arduino. So here we have the tools needed for the inductance meter through Arduino. First, if you see in our circuit, it is already done because it will take a long process to create this circuit one by one. Will be recorded through the camera. Now let's just identify the components needed for this circuit. First is we need we will be identifying the components from left to right. Okay, first is this jumper wire connected from pin 12 of the Arduino, and it is connected in the end of at the side of the resistor, 150 ohm resistor, and then followed by the diode. Then at that side of that diode is there is also a jumper wire connected, this red jumper wire, which is connected to the other side of the non-polar capacitor, which is also an important tool needed for this circuit. So if you see, it's a very messy circuit. It has many wires, it has many connections. Okay, let's just also refer to the schematic diagram of this circuit. Okay, let's continue. So here is the capacitor. Then the other side of the capacitor is connected to the ground, as you can see, this part, and this black pin, this pin, it is connected in the ground pin of the Arduino, that black jumper wire. At the same time, in the ground is there is also a pin connected to the fourth slot or fourth pin of the comparator. So there it is a special, one of the special components of inductance meter capacitor. There is In fairness to the other circuits, the resistance and capacitance meter, inductance meter uses a special type of component called comparator, which is designed for this circuit, to the units, to the terms, to the frequencies that are used in this circuit, which is the LC circuit. So it is important in this the comparator. And now, if we will be testing the inductor, let's say this inductor, its value, we will be putting this in this pin. I will be connect it along with the connection in the diode and the red jumper wire connected to the end of the capacitor of the unpolarized capacitor, and the other side is connected in ground. So as you can see in the connection, that other side of the inductor is connected through a solid wire along to the down portion or bottom portion of the breadboard, together with the connections that we've discussed earlier, including the connection to the ground pin of the Arduino. Okay, so now, in testing for the inductor in this inductance meter through this Arduino, in this project, we can see in the serial monitor in the Arduino app that the unit is in microhenries rather, indicated in microhenries. And also, there is a tip that the bigger amount of your capacitor and the bigger amount of your inductor, it makes a more accurate result in the serial monitor. So a bigger or a higher amount of the values for the capacitor and the inductor, a more accurate result in the serial monitor being displayed is also more accurate, other than the lower values of the inductor and the capacitor, non-polar capacitors. You can see that, yeah, as the same with the previous circuits that we've made, with the same with the previous projects that we've made, it is not really that accurate for the result. It is not exact for the result on the serial monitor displayed. In fact, it only gives a rough estimation of your value of the inductance, capacitance, and resistance for the previous projects. And it only shows that through Arduino, with these tools, with these components, we can create an alternative or DIY, do-it-yourself projects and circuits that tells us the values of the capacitance, the value of the capacitor, the inductor, the resistor, and much other more. So I think that you've learned a lot in our videos. First, we have the capacitance meter in the through Arduino, and this second part, which is the inductance meter via the Arduino. So I hope that you learned a lot from our holiday season special vlog of TechTrends. Thank you and happy holidays!